You walk into your kitchen at 6 in the morning barefoot, and your foot instantly sinks into a lukewarm, greasy puddle of rotting gray water. The hardwood planks are already cupping. You open the dishwasher door, and instead of clean plates, you're hit with a suffocating cloud of dark, burnt electronics odor mixed with stagnant food waste. The slick, glowing touchscreen on the top lip of the door is dead. Black screen. Nothing. The machine is barely 3 years old, cost you a cool $1,200, and it just committed suicide in the middle of the night. You call a technician hoping for a simple fix, but the verdict is a total mechanical write-off. The corporate showrooms want you to believe this is just bad luck, a random glitch in a highly complicated appliance. It isn't. The showrooms lie, but the teardown bay never does. But step into the teardown bay, and the illusion shatters. Every crushed circuit board, every shattered plastic impeller, and every flooded kitchen floor traces back to a highly calculated shift in appliance manufacturing. These are straight-up engineering crimes. Today, we are tearing into the anatomy of modern kitchen failures to expose the exact hidden choke point engineered to kill your machine at month 36. We are going to map out the microscopic money extraction trick that turns a worn-out 50-cent rubber gasket into a devastating $400 repair bill. And I am going to reveal the technician blacklist secret, the specific hardware configuration that makes guys who actually turn wrenches violently reject 80% of the showroom floor, because beneath the sleek brushed aluminum and the quiet wash promises, almost the entire industry has quietly agreed to build disposable, planned obsolescence garbage. Almost. We are going to name the one single brand Miele that is still stamping out heavy metal tanks like it is 1990. This is where the engineering math robs you blind. To understand why Miele stands alone on the mountain, you have to look at the engineered, rotting core of the competition. Let us look at the showroom seduction first. You walk into the big box store, and you are immediately hypnotized by the sleek, minimalist fascia, the hidden top control tablets, and the promise of a whisper-quiet 40-decibel cycle. They sell you on the Wi-Fi connectivity and the delicate blue LED floor beam. They want you looking at the lights, not the mechanics. The root of the rot is shockingly basic. Look under the cosmetic skin at the hidden choke point. Notice the primary wash motor assembly. Instead of a heavy, bolted metal housing with replaceable mechanical seals, you will find a proprietary sonic-welded plastic block. This is the heart of the fused plastic pump ransom. The chain reaction is simple, brutal physics. The microscopic grit from your dirty plates bypasses the flimsy, uncleanable mesh filter at the bottom of the tub. That grit gets violently sucked into the spinning plastic impeller inside the motor housing. Over a few hundred cycles, the grit acts like aggressive sandpaper, chewing away at the ultra-thin plastic walls. The impeller shaft starts to wobble. Microfractures spiderweb across the sonic-welded seam. Eventually, under the intense pressure of 150-degree water, the seam blows out completely. You will not hear a loud explosion. You will just hear a violent, rhythmic thud, followed by the absolute silence of a dead machine. The scalding water jets out, instantly soaking the bare wire harnesses routed deliberately below the leak point. Look closely at the copper pins on the main logic board when this happens. The microscopic condensation bridges the bare circuit traces, turning the whole computer into a melting, sparking brick of slag. The living room consequence is exactly what you smelled that morning, the unmistakable, acrid stench of a fried motherboard baking in stagnant humidity. It is a thermodynamic nightmare. The wallet consequence. You are looking at mid-hundreds for the logic board and another $400 for the pump assembly, pushing the repair far beyond the cost of a brand new budget machine. Any guy who spends his days elbow-deep in stagnant drain water knows exactly which units are designed to go straight to the landfill. Gravity and thermal expansion always win. Did you really think a motherboard bolted directly above a boiling steam vent was going to survive a 5-year daily cycle? Ask any veteran technician carrying a multimeter, and they will tell you the same thing. The entire ecosystem is rigged against longevity. The metal is too thin, the plastic is too brittle, and the electronics are entirely unprotected. But then you drag a Miele into the shop and pull the heavy side panels off. The contrast on the workbench is completely undeniable. Miele is the single remaining heavy-duty holdout. The showroom pitch for a Miele is not about connecting your appliance to a smartphone app to get a push notification when your forks are clean. The seduction is the sheer, brutal, physical weight of the door. Look beneath the stainless tub of a Miele Classic Plus or an 8000 series. You will not find a flimsy plastic base or a glued-together disposable motor. You see thick, cold-rolled steel framing. Notice the wash pump. This is a massive, discrete mechanical unit bolted together with actual heavy-duty fasteners. They do not rely on the fused plastic pump ransom to force you into a premature upgrade. Because the pump housing is heavy-gauge polymer and bolted steel, and the impeller is designed to handle extreme debris. The microscopic grit does not chew through the sidewalls. The water pressure remains constant and forceful. The seals are thick, isolating the moisture entirely within the wash cavity. There is no steam venting straight into a delicate logic board. When you run a Miele, the living room consequence is dead silence, punctuated only by the visceral, satisfying sound of thick water violently smashing against heavy metal, cleaning everything flawlessly. There is no burning smell. There are no puddles. The wallet consequence is steep, commands a massive upfront premium, easily hitting $1,200 to $2,000, but it amortizes 2 pennies a day over a 20-year lifespan. It is the only brand repairmen trust because they hate fixing things off the clock. We look at the bare wiring harness in the shop, and we already know what your error code is before we even plug the diagnostic tool in. You start to see the deliberate trap laid out when you look at the replacement protocol for the competition. The other guys figured out that if they make the parts unrepairable, they completely control your bank account. It works like a cynical playbook. The fragile plastic diverter valve cracks. The manufacturer refuses to sell the 50-cent internal seal. You are mandated to purchase the entire lower sump block. You abandon the machine because the part is perpetually backordered. That isn't a manufacturing defect. That is a perfectly executed wallet extraction event. Now watch how the extortion play unfolds on the physical touch points. Look at the basket mechanisms on a standard big box machine. They use ultra-thin nylon wheels snapped onto brittle plastic axles. After 2 years of thermal shock baking heat, followed by cold water, that plastic turns into chalk. It shatters under strain. The moisture eats the metal alive beneath the cheap PVC dip, leaving you with spongy metal flaking like wet chalk onto your clean dishes. You go to pull out a heavy load of stoneware, and the entire rack collapses. The manufacturer wants $80 for a new row of cheap plastic wheels. With Miele, the rack architecture is built on heavy-gauge steel wire, coated in thick, commercial-grade nylon. It feels like closing the door of a German luxury car. Cheap materials always guarantee an expensive failure. Here is the exact point where the corporate mask slips. The industry lobby pushes for extreme water and energy efficiency mandates, which forces the integration of highly fragile, tightly packed digital sensors into a wet, hostile environment. They use those mandates as cover to implement the fused plastic pump ransom across their entire product lines. They wrap a disposable, plastic-welded, sensor-heavy core in a shiny stainless steel wrapper and sell it to you as a premium upgrade. They want you locked into a rolling catastrophe and a 3-year replacement cycle. But you do not have to play their game. When you walk onto the appliance floor, you need to strip away the marketing hypnosis and evaluate the hardware like a forensic auditor. Here is your counterstrike checklist. Find the heaviest stainless steel interior available. Look for hard physical buttons on the door. Demand a discrete mechanical wash pump assembly. Reject anything with a glowing touchscreen tablet. Skip the mandatory smartphone application connectivity module. Check the hinges for thick, cold-rolled steel. You are looking for mass, friction, and modularity. Every ounce of digital convenience they sell you is just another ticking time bomb wired directly to your wallet. You want an appliance that does exactly one job with brutal mechanical efficiency. Start interrogating the build quality. Stop accepting premature death as a natural law of homeownership. Hit that subscribe button if you are ready to stop feeding the disposable appliance cartel and start putting heavy iron back in your kitchen. When you reject the sonic-welded plastic block, you stop funding the landfill and start starving the suits. Evidence wish list. Parts diagram showing a fully assembled Miele wash pump next to a fused plastic big box pump. Close-up B-roll of a melted scorch-marked dishwasher logic board with visible condensation damage. Screenshot of a manufacturer parts portal showing a 50-cent seal marked as not sold separately. Anecdote prompts. Have you ever had a top-tier smart dishwasher fail catastrophically just outside the warranty window? What part broke? Technicians. What is the most ridiculous wait time you have seen for a proprietary main control board? Has anyone here inherited a 15 to 20-year-old Miele that still outperforms brand new machines?